Okay, welcome back everyone. In this video we're going to take a look at an example problem for using the ideal gas law. So this is number 41 on page 362, and so what it says is that we have a steel belted radial tire that's inflated to a gauge pressure of 30.0 pounds per square inch. So that's what they call the gauge pressure when the temperature is 61 degrees Fahrenheit. Later in the day, the temperature rises to 100 degrees Fahrenheit. Assuming that the volume of the tire remains constant, what is the tire's pressure at the elevated temperature? Okay, so let's take a look at what we have here. We have P1, the starting pressure. We have T1, the starting temperature. We have P2, the unknown final pressure. And we have T2, the final temperature. And we're also given that V1 is equal to V2 because the volume stays constant. Now, before we can apply the ideal gas law to this, what we have to do is add in what's called the gauge pressure. In other words, we have to add in, whenever it says gauge pressure, to get the true pressure. I can write today. You have to add 1 atmosphere. So in other words, a gauge is kind of already canceling out atmospheric pressure, but we need to take that into consideration when we do the calculation. And so remember that 1 atmosphere is 14.7 pounds per square inch. So that means that the starting pressure is actually 44.7 psi. And so what we want to find is the final pressure. Okay, now we have to be careful and think about, do we have to convert our units? It turns out that for pressure we don't, but for temperature we do. So we set up the ideal gas law, and we know that P1 V1 is equal to N1 R T1, and P2 V2 is equal to N2 R T2. So what I'm doing is I'm starting at the very beginning, and I'm going to add in the fact that V1 is equal to V2 is equal to constant, so we can sort of take that out. And we know that hopefully the amount of gas, N1 and N2, stays constant. So I can solve these two equations for R. I have R is equal to P1 over T1, and R is equal to P2 over T2. Well, R is always equal to R, so that's where we get P1 over T1 is equal to P2 over T2. And as long as we have P1 in PSI and P2 is also in PSI, and as long as we've added in the air pressure that already exists, the 14.7 PSI, then we're good. Temperature, on the other hand, we're going to have to convert. So it turns out that the first temperature, T1, or 61 degrees Fahrenheit, well, first of all we have to convert that into Celsius, and that's about 16.11 Celsius. And when we add 273 to that to convert to Kelvin, we get that T1 is actually about 289.3 Kelvin. Likewise, T2, by the same process, we start with 100 Fahrenheit, convert that to Celsius, and we add in 273, so that's 310.9 Kelvin. So it's very important to make sure that the temperature is in Kelvin, because if we had, for example, 44.7 psi over 61 Fahrenheit is equal to X over 100 Fahrenheit, that's going to give us a very different answer than if we had 44.7 psi over 289.3 Kelvin, is equal to X over 310.9 Kelvin. In other words, the ratio of 61 to 100 is way different than the ratio of 289 to 310. So that's why this is important. We then solve this for X, so X is also our second pressure, and we find out that P2 is 48.03 psi, but now we have to subtract back out the 14.7, and so the true pressure is about 33.3 pounds per square inch, and so that's our final answer. Okay, so this was a little bit tricky because we had to make sure to use Kelvin, and we had to add in 14.7 psi for the so-called gauge pressure. Now, when do you know to use the extra 14.7? Well, anytime it says gauge pressure, you add 1 atmosphere. If it doesn't say that, you don't have to worry about it. Okay, so that wraps it up, and in the next video I'm going to offer up a proof of the ideal gas law.